Now that we talked about propositional forms, in this video we are going to answer the question when are two propositional forms equivalent? Okay, the definition is really simple. Two propositional forms are equivalent if and only if they have the same TT, truth tables. Okay. At some point I will explain the difference between if and only if. There is a huge difference between those two. Okay. Let us say we have proposition P and proposition not P. So you know that if P is true, non-P is false, and if P is false, non-P is true. Now, let us see what happens to this proposition. Not P. Not P. Okay, here not P is false, so this one is true. And here not P is true, so not P will be false. But if you look well, this column or this table and this one, they are the same, right? True, false, true, false. Okay, so you can say that P is equivalent to not P. This is the same. Okay, so anytime you do the truth table and you get the same truth table for any propositional form, you know that the two propositional forms are equivalent. Okay? Well, this was a bit too easy, right? So let's do something a bit more sophisticated. Let us say we have P and we have Q. Okay? Let us say true, true, false, true, true, false, and false, false. Right? Okay. Now let us do P and Q. So they both have to be true, right? P and Q. So true, false, false, false. Okay. Now let us do P and Q, but let us do the table for not P and Q. So this one is true, false. So this is P and Q, so this is not P and Q. So this table will be the opposite case of all this table. True, false, false, true, false, true, false, true. Right? Okay. What about not P? Let's look at this one. So it's only the negation of this one. So that will be false, true, false, true. Let us do not Q. So this is the negation of this table. So it will be false, false, true, true. Right? And now this is the one, this is where I wanted to get. Let us do the table for not P or not Q. So we only need one of these two to be true in order for this to be true, since this disjunction, right? So false, 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 the only case where it's false. So true, I don't need to check this information now. True, false, true, true, so I don't need to check this information again. True. Okay, so you see, for those that are used to this, when you look at this one, you say not P and not P and Q. So not P and Q. And some of my viewers that are more used to this will immediately say, well, this is the same as, I don't like to put this equal here, but for the time being it's okay. Like not P, and not and. So not and is the contrary. The opposite case of and is or, and not Q, right? So not P or Q. Now you can ask, well, can we say that those two, can we say about these propositional forms that they are equivalent? Yes, this is true. These two propositional forms, they are equivalent, because if you look at the table here, right, it's exactly the same as the table here. Okay, so these two propositional forms, they are equivalent. So you see the negation here. At the end of the day, here you're saying P and Q. So you're saying I have P and Q. Here, P and Q. I have P and Q. But you have a negation here. So what you're saying is you're saying you don't have, because that's a negation, you don't have P, you don't have both. We should put here you don't have both P and Q. That is correct, because you don't have P and Q. Well, this is not a well-defined proposition, okay? Or it's not, it would be well-defined, but not what we want to say. So what we are saying here is you don't, this is the you don't have this one. And what is this one? Both at the same time, P and Q. Okay, so you replaced this by this, not P or not Q. So we can say this: you don't have P, or you don't have Q. Okay, as you can see, even in the way you talk in your day-to-day life, logic will be there. Okay, and trust me, if you keep working on logic, you will have fantastic surprises where you're gonna find that lots of things that you said before were terribly wrong. That's why logic is such an important tool for philosophy, computer science, informatics, mathematics, etc.